Hello, and welcome to Lesson 1, Combining Like Terms. This is number 1, if you want to label that at the top of your page. You don't have to, but could help you stay organized. So, when we combine like terms, first we have to talk about a bunch of vocabulary words that will help us understand this. So we have the word term, and in math, what a term is it's any set of numbers or letters that are right next to each other, but there's no plus or minus sign in between it to separate it. So, any numbers or letters next to each other with no plus or a minus sign between them. At this point, I would just like to note that sometimes you might need to pause the videos to write and catch up with writing, and that's entirely okay. Our next vocabulary term is mononomial. The word nomial, this part here, nomial means term, and mono means one. So a mononomial is when you have one term. An example of this might just be 2xy. So it's a number and two different letters, but they're not different because there's no plus or minus sign in between them. The next word is called binomial. Bi means two, so that's two terms. For example, 2xy plus 3y's. Now these are two different terms because here's a 2xy and the plus separates it from this 3y. Our next word is trinomial. Tri means three, so it's three terms. For example, we could have 2xy's plus 3y's minus 5x's. And the 5x is a whole different term because it's separated by this minus sign. And finally, polynomial. Poly means many. So polynomial is more than three terms. So in math, we're going to have some common terms. Those terms are just a number by itself with no letters, x's, y's, xy's, x squareds. A squared is a very tiny 2 in the upper right-hand corner like that. Later you will learn exactly what it means to square something. For now, it's just a term, just like y squared. And you can think of any of these terms as like, these could be bananas or apples or oranges or peaches. What matters is that they're just different. An x is different from a y, which is different from an xy, which is different from an x squared, and it's different from a y squared. And it's different from just a number by itself. And they're all different terms. So what does it mean to combine like terms? It means any of them that are the same, like if I have an x written somewhere and more x's written somewhere else, we combine them and count how many we actually have altogether. So for what does it mean to combine like terms? To count how many of each term we have. Okay. So for our first example, we have a bunch of terms here. If we were to count them, here's 1, 2, 3, 4, 5, 6, 7, 8. 8 different terms that are separated by the plus and minuses, which definitely makes us a polynomial. But we have some of the terms written more than once because there's multiple of them, and we can combine the ones that are the same. So our first term we have here says 6x. So the type of term it is an x term. The 6 means that there's 6 of them. So that if I keep looking down my line, right here you'll see I have a minus 2x. It's very important when you look at how many you have, it's not just the number in front, it's also the sign. So it's not that there's 2 x's, it's a minus 2, which means it's negative 2 x's. So when I combine those two things together, 6 x's minus 2 x's ends up giving me a total of 4 x's. My next term is a y term, and I happen to have negative 4 of them right here. And if I keep looking later on, I have a minus another one right there. Note that that says minus y, and so if I ask how many y's there are, well, technically it's negative 1 y. Because if there's no number in front, it just means that there's one of them. So here I have minus 4, and then later on I have minus 1. So when I combine them together, negative 4 minus 1 is negative 5. Negative 5 y's. Our next term is a just number term. It's just minus 3 with no letter with it. So it's a just number. Later on, I have another just number term right here, and it says plus 1. So if I combine that together, negative 3 plus 1 is negative 2. And finally, I have next xy terms. So right here is 3 xy's, and over here it's plus an xy, which means plus one more xy. So remember, if there's no number in front, you can write that invisible 1. So 3 xy's plus one more xy is a total of 4 xy's. So now, all of my terms have like terms, the ones that are the same, got combined because we counted how many of each type we had. Now for example 2, we start with an x squared term, and there's one of them because it just says x squared. And then later on, I have 5x squareds right here. So all together, I have 1 plus 5, 6 x squareds. Next I have an x term, and there's negative 3 here, and then later on I have plus 3 right there. Well, negative 3 plus 3 is 0. If I wanted to, I could write plus 0 x's, but if I have none of them, why would I waste time writing it? They're just not there. They don't exist. So we move on to our next term. We have a y squareds, and there's 2 right here, and later on it's a minus a y squared. Remember, that's minus 1 because there's no number, so 2 minus 1 is just plus 1 y squared. This time I wrote the 1 in front, but you don't have to because it's just 1 y squared, so you can just write y squared. And next, I have this minus y term, and it's a y, so if I look, I don't have any more just y's. So it has no one to combine with, and when there's no one to combine with, you just write it. So there's a minus y, and then this one was used, but then I have this minus 6, and again, there's nothing for the minus 6 to combine with. So we just, at the end, write minus 6. And now our long expression has been combined into a shorter one with all of our like terms combined. So go ahead and flip your page over, and we're going to make it a little harder. So sometimes these have equal signs. And when there's an equal sign, there's a couple rules. Rule number 1 is you have to draw a wall at the equal sign. So here's a wall at our equal sign. Okay? So when you have an equal sign, the left is equal to the right. They're not all together. They're on 2 separate sides of the wall. And that right now they're considered to be the exact same. So first, it's okay to combine like terms if they're on the same side of the wall, but only the same side. So if I say, do I have any more x squareds, Not on this side of the wall. Do I have any more just numbers? Not on this side of the wall. Do I have any more 2x's? Not on this side of the wall. But do I have any more y squareds? Well, this is 5y squared and then minus a y squared. So those are actually like terms that are on the same side of the wall. So it's okay for those to combine together. So I'm going to rewrite what I have so far. I have 6x squareds plus 4 plus 2x's. And now I'm going to combine these like terms. 5y squared minus a y squared gives me a total of 4y squareds. And then I still have my equal sign at the wall. On the right side, do I have any more x's? Not on the right, so I'm just going to rewrite it. Do I have any more just numbers? Not on the right, so I'm going to rewrite it. Do I have any more x squareds? Nope. And also no more y squareds. There's nothing on the right that's a common term or a like term. So there's nothing to combine, so we just rewrote it. So now, when there's an equal sign, our goal is to get everything on one side. And then once they're all on the same side, we can put them together. In order to move across the equal sign, you end up having to flip the terms over. So 2, we have to flip everything over by doing the opposite. And I'll explain what I mean by doing the opposite in a second. So I think, and it doesn't matter, we can move all these over here or all these over here. I like it better to move everything to the left. I like all my stuff on the left side. So that's what we're going to do, and we're going to just take it step by step, thing by thing. So we right here have an x. I want to get rid of it. I don't want it on the right side. Well, to make having an x become 0, I just have to get rid of that x. I just need to minus that x away. However, right now they're equal. And if I'm going to minus an x, they're not equal. So I have to also minus an x on the left side too. So I'm going to find my x terms. They're right here. And I'm going to minus that x. And then you draw a line if you want to do this math. So this 6x squared didn't have any math to do. This plus 4 has no math to do. But this 2x has a minus x underneath it now. And if you have 2 x's and you're minusing an x, then you still are left with 1x. And you don't have to write that one. But this y squared right now, this 4y squared, have nothing to do. Now over here, on the right side, well, I took this x and I minused it away and I flipped it over here. So now that's not there anymore. It went away. But I still have the 3, the x squared, and the minus y squared. That had nothing to do mathematically yet. But now if I want to get rid of this 3, well, I have that 3, so to get rid of it, I'm going to minus it away. And I'm going to minus it away from my 4 over here. So I'm going to do my math. 6x comes down, 4 minus 3 is 1. The x comes down, the 4y comes down, y squareds. 3 minus 3 becomes 0, so it flipped over like I wanted. I still have my x squared and my minus y squared. Now technically, so far, we've been minusing, first we minus the x, then we minus the 3. Well, you can do it all in one step if you want to, which I'm going to show you right now. I could just minus this x squared to make it go away from my x squareds over here. And since this is a minus y squared, I do the opposite by adding the y squared. Because remember what we're doing is doing the opposite, because minus something plus something makes it become 0. So I need to add my y squareds. So when I do my math, and I don't have room, so I'm going to write the answer over here. 6x squared minus an x squared becomes a total of 5x squareds. Then this plus 1 is just there. This plus x is just there. Here I have 4y squareds, but I'm adding another y squared, so I have a total of 5y squareds. And then equals, everything's gone now. I got rid of this, I got rid of this. I flipped everything from the right over to the left, so there is nothing over here. And remember, our goal for these is to always have it equal 0 by the end. Whenever there's an equal sign, and you're combining like terms, your answer should say equals 0. And finally, for our last example, we're making it a bit harder because we're adding parentheses. So when there's a number in front of a parentheses, it means you need to multiply into the parentheses. But into the parentheses means multiply into every single term. So right now there's a 2 in front of a parentheses. It's a positive 2 because there's no negative sign in front. I need to multiply it into this one, and this one, and this one. We're going to go one at a time though. So 2 times negative x squared. Well, it's a pretend negative 1 that we don't have to write. And 2 times negative 1 is negative 2, and they're x squareds. Then I times it to the 2xy's. Well, 2 times 2 is 4, and they're x y's. Then I also have to times it to the plus y squared. Remember, it's 1y squared. So I'm going to write the 1, and 2 times 1 is 2, and they're y squareds. And then at the end there's this minus xy. We just write it. It doesn't get multiplied because it's not inside the parentheses as well. We just write it at the end. And then we have our equal sign. And this 3xy has nothing to multiply to it, so we just rewrite it. However, now we get to the minus 3. We don't just rewrite the minus sign because it's a part of the 3. It's a negative 3. And that negative 3 needs to get multiplied to that x squared. Well, since the x squared is a positive 1 x squared, negative 3 times positive 1 is minus 3, negative 3. And they're x squareds. However, now I have to multiply negative 3 to negative 1. And a negative times a negative becomes a positive 3y squared. Now, because there's an equal sign, we first look at the left. Are there any more? I'm going to draw my wall to separate my two halves. Are there any more x squareds on the left to combine with? No. Does this 4 have any xy's? Any more xy's to combine with? They do. Here's 4 xy's. And then on the same side of the wall, there's another negative xy. So 4 xy's minus an xy becomes 3 xy's. So I rewrite this term because it's still here. And I have 2 x squareds. These combine to plus 3 xy's. And there's still plus 2 y squareds. And they equal. There's on the right side, there's no more xy's to combine with, no more x squareds to combine with, and no y squareds to combine with. So we just rewrite everything we have. 3x squareds plus 3y squareds. Now all my like terms are combined on the left, and they're all combined on the right. But we're not done because we want to flip all these over here. So we're going to do this all in one step instead of step by step. Here we have 3 xy's. I'm going to minus them away. I'm going to line them up with my other xy's, and I still have to minus them away because what you do on one side is the exact same as the other. Now this is minus 3x squareds, so to do the opposite of that, we add 3x squareds. I'm going to add them, my 3x squareds, over with my x squareds. And then this says plus 3y squared, so to undo adding, you subtract the 3y squareds. I find my y squareds, and I subtract my 3y squareds. And then I work through each pair. So negative 2x squareds plus 3x squareds gives me a positive 1x squared. I don't have to write the 1 because it's positive, or because it's just 1. Net plus 3xy's minus 3xy's becomes 0 3xy's. Because 3 minus 3 is 0. But we don't need to write that we have nothing. So I just don't write anything and I move on to my next one. So plus 2xy's minus, or that's not an xy, that's a y squared. So plus 2y squared minus 3y squared becomes negative 1y squared. And again, I don't have to write that 1. And then equals 3 minus 3 is 0. Minus 3 plus 3 is 0. And plus 3 minus 3 is 0. So all these went away just like we wanted them to. They all flipped over here. And we're left with nothing. And now we have combined like terms.